Hey, welcome to Ones and Zeros. My name's Ben, and today we are doing another video that is the first video in a new series. In this particular one, we're going to be taking a look at the project with the robot that I mentioned during the last update video for the channel. Apologies for taking a while to actually get around to this one, but we're basically going to have a bit of a look at what we're going to be looking at achieving over the course of this video series, the different bits of hardware and things that we're going to be working with, as well as the actual robot platform that we're going to be basically developing a brain for over the course of this series. So I'm going to be allowing us to take some of the stuff that we've been covering in the various STM32 series, so discovering STM32 as well as the STM32 basic series, as well as some of the stuff that we've been covering with FPGAs. And on top of that, this project is also going to get us delving into some ESP32 stuff. Now, there will be simpler ESP32 videos coming out as well. Especially as far as sort of simple little projects like the LEDs on the shelf behind me, which are being run by a little ESP32 module. It's running custom code to do the lighting effect there, so quite handy little boards that we haven't really covered at all on the channel so far, but that will be stuff that I want to get into a little bit more moving forward. So basically, the particular robot platform that we're going to be taking a look at is a hexapod robot that I purchased online that is intended to be used with a Raspberry Pi. However, me being me, don't really want to be using a Raspberry Pi for it and using a bunch of code that's already written. I want to create something from scratch and getting to share the entirety of that process with all of you guys, so that you can get a bit of a feel for how to go about actually creating your own robot brain if you want to. Don't have to use this particular platform. A lot of the particular things that we'll be looking at will be suitable for various different robot platforms, things like that. But let's take a little bit of a look at what we're actually going to be working with and sort of the plan that we're going to be taking over the course of this series. I'll also have a bit of a look at some of the test setup that I've been using to start getting everything up and running. So let's jump over to this camera, and apologies for the lighting. Being a black robot, it doesn't actually show up that well on camera as much as I have a bunch of different lights currently set up. Let's see if we can actually improve this slightly. It's really hard to get this actually lit well without things not coming out correctly. But basically what we've got here is a hexapod robot. So it's got 6 legs and a head that's basically a gimbal, so it can rotate and pitch up and down. As I mentioned, it's initially intended to be controlled by a Raspberry Pi, but we're going to be taking a custom approach with it. So underneath the robot, it does have battery holders for some 18650 cells, which we will be using eventually in the project. However, at the moment, I do have it running off my lab power supply, which is supplying the power just for the servos at the moment, using 2 separate channels of the power supply there, one for each set of 3 legs. So the left set of legs is powered by one channel, the right set is powered by another channel. We do have a custom board, which I've created just from a typical breadboard, which is taking our 3.3 volt PWM signals, which is coming in on this bunch of cables into the middle here, and then going through a bunch of logic level converters, which we'll have a closer look at in a moment, and then going out to the various servos for each of the legs. The servos for the head are not currently connected. A bit of hair on there, we'll get that out of the road. Basically, each leg has 3 separate servos. We'll see if we can get a bit of a closer look. Hopefully the autofocus wants to do its thing here in a moment. Try and get it to focus a little bit better there. Maybe. So each leg is basically made up of 3 servos. So we've got one servo for the knee joint. We've got another servo which is doing the hip joint, so lifting the leg up and down, and then another servo in here which is allowing the entire leg to rotate, like so. So all in all, just for the legs, there is 18 servos, so 3 per leg and 6 legs, and then another 2 of the same servos which are being used for the head as well, in order to allow that to move up and down and rotate left and right. There is also a camera built in and an ultrasonic distance sensor, although we are going to be adding additional cameras and other sensors and things like that to the platform moving forward as well. See if we can get some more light on this. Hopefully we can get it so it doesn't reflect too much off the body. That's a little bit better. So hopefully you can see things a little bit more clearly there. Again, because it's all black acrylic, it does make it quite hard to film against a black desk. But basically, have been working on a bit of test code for this, which I will be showing you some of what it does so far. It doesn't do a whole lot at this point, but essentially the main thing so far has been to get the servos for the legs up and running and developing an inverse kinematic system so that what we're able to do is, rather than having to worry about controlling each of the servos individually, we have a STM32 over here, a H7, which is currently doing all of the inverse kinematics calculations so that we can actually provide it a specific point in 3D space relative to the robot where we want the tip of the toe to actually sit, and it will calculate all of the joint positions in order to get the toe of the robot to that particular space or spot. So we do already have a bit of movement happening. The main system so far basically consists of the board to change all of the logic from 3.3 volt to 5 volt, as well as supplying power to all of the servos, which is what this board here is currently doing. Let's get the camera a little bit closer so that we can have a look at that. So that is that board right there. So we can see the logic level converter boards. We've got 6 of those, 3 for each side. So allows us to have up to 24 channels worth of servos, although we're only going to be using 20 of them initially, but it allows us to add 4 more servos if we want to. These servos also have a little bit of power behind them, MG996Rs, so Metal Gear servos, which during some of the testing, the robot can actually hold quite a bit of weight when it's holding itself up. We do have it sitting on a couple of boxes at the moment just so that we can demonstrate some of the movement. Those servos are being driven by some hardware in the FPGA on this Terasic DE0CV board. So it's currently got 18 servo drivers operating in hardware at a really high frequency so that we can get really fine movement out of the servos if we need to. And that is taking its data from the STM32H7 board, which we've got here. The H7 is basically being fed positions for each of the toes, and then it's calculating the joint positions for all of the servos, feeding that data over to the FPGA, and then the FPGA is then providing all of the PWM signals for the servos. So over the course of this series, we're going to take a look at all of that sort of stuff. At the moment, we also have a STM32 F7 discovery board over here, which is basically currently operating as a little bit of a remote control for the robot as well. So it's got a couple of joysticks on it. It's not actually connecting all of that well at the moment, so it wants to restart, but basically got that one there. The GUI that we've got running on here is all custom. This is running on top of all of the code that we've been developing in the... See if we can actually get it to stop misbehaving for us. So it's running on top of the code that we've been working on the Discovering STM32 video, and a few additional bits and pieces, as well as a custom UI system on top of that, which we'll also be looking at on the channel, and just rendering out a few icons and things like that to allow us to have a bit of control. We've got a rotary encoder with a push button. We've got a couple of joysticks, as well as a few other push buttons, one on this side and then a couple of shoulder buttons over here as well, to allow us to have a bit of additional control over the robot. So that's kind of the setup that we've got. We're also, as I mentioned, going to be making use of some of these ESP32s. So although the remote is actually wired at the moment, we will use a couple of ESP32s to allow that to communicate to the robot wirelessly as the project moves forward. And we're also going to be using some ESP32s on the robot itself to be processing some of the higher level stuff, as well as leveraging the FPGA to be able to handle some of the sensors. And we're also going to be developing some cores for the FPGA that allow us to do a little bit of neural network style processing in hardware as well. So there's a fair bit that is planned for it. And overall, our goal moving forward is going to be firstly getting the robot up and walking with the remote so that we can actually walk it around. Over the process of doing that, it's going to be tethered. So we are going to be using a fixed power supply for that. But the overall goal will be to have it autonomous so that it can actually wander around and do its own thing and kind of just let it loose. But the remote will allow us to still be able to override it or control it manually, or get it to do various things semi-autonomously. So there's a fair bit that we have planned for this particular series, and there's probably going to be quite a few episodes in order to achieve the various things that we are looking at doing. At the moment, like I said, we do have the inverse kinematics test code up and running. So we move the camera so that we can get a view of the robot again. Would help if I had a few more cameras so that I could just jump between cameras. There we go. So at the moment, the robot is basically just being told to position the tips of its toes just out from its body by about 10 centimeters and just down from the bottom of its hip joint. And it is currently being powered and is currently holding weight. There is an emergency stop button which we can make use of on the remote, and if we hit that one, we can see that the legs basically stop being powered. So basically it just kills the PWM signal, and as a result the servos in the legs just stop reacting. If we turn it back on, we can see that those legs do go back to actually holding weight again. We do have a few different modes to allow us to go through and test and calibrate the legs at this point as well. Like so that we can get it to basically spread its legs out to basically a T-pose. So all of the servos are currently at their mid position at the current point in time. And we can also go through and we've got a couple of modes to be able to test the inverse kinematics and the positions of the servos as well. So the front legs being directly forward, or we can have it so that the back legs are directly backwards, things like that as well. Or we can go back to the normal pose. So we do have it sitting up on a couple of boxes at the moment. However, if we move those guys out of the road and just pop him down on the table, we can see that it is actually holding its own weight. Let's see if we can drop the camera down a little bit and try and get a bit of a view of that. See if I can get a bit more exposure on that. There we go. It's a little bit better. Fortunately, turning up the ISO is going to give us a worse shutter speed, but as we can see, the robot is actually currently holding its own weight and can sustain quite a bit of pressure being placed on it before it starts to struggle. At this point, the lab power supply will actually give out or hit its current limit before the servos actually give out. So it says in the documentation that it's capable of carrying over 1 kilogram worth of weight on top of all of the circuitry that it came with. So it does give us quite a good platform to be able to work with to see what we can achieve. So that's a bit of a look at what we're going to be covering over the course of this series. I will also be working on making sure that we can potentially see everything a little bit better over the course of the series so that it's not quite as dark. Again, the black acrylic and black servos doesn't exactly film that well against the black desk. But it will also allow us to be able to take a lot of the stuff that we've been working on over a bunch of the other video series on the channel and start seeing how it gets implemented in a particular project and what we can do with it and the different ways we can make use of things, whether it be the GUI on the remote or whether we're doing inverse kinematics calculations or hardware to be able to drive servos or run sensors, things like that, and seeing how we can take a bunch of different platforms and combine them together into one seamless system that works together really well integrated. So that's kind of a bit of a look at that, and in the next video we're actually going to start to take a bit of a look at some of the servo drivers that we've implemented in the FPGA, and following that we'll be taking a look at some of the inverse kinematic stuff. Over the course of that sort of thing, we will be taking a look at like matrix maths and manipulation of 3D points in 3D space and that sort of stuff as well. So there'll be quite a lot of interesting stuff that we're going to have over the course of this series, and hope that everyone's going to enjoy it. It's certainly something that I've been having a lot of fun playing with. If you've got any questions or anything like that about any of that, definitely feel free to jump onto our subreddit or send me an email or leave a comment under the video. I'm certainly happy to answer any questions. A huge thank you to all of the patrons that have been supporting the channel. You guys are amazing, especially considering that there hasn't been any new videos for quite a while now. However, just starting to get back into the swing of things, and there will be a bunch more videos coming out, not only for this series but for a bunch of the other series that we've been doing on the channel as well. So I hope you guys look forward to that. And big thank you to all of the people that have just been watching and liking and subscribing. That's really awesome to see how many people have been interested in some of the stuff that we've been producing for the channel. Definitely inspires me to want to keep producing more videos for you guys. So thank you a lot for that. It does mean a lot. Hope you have a wonderful day or night or morning or evening, whatever it is in your part of the world when you're watching this. And thank you for watching.